There are multi-stage problems involving bearings and trigonometry together. In those kinds of problems, you need to read problems carefully and draw a sketch to figure out the movement in the problem. So, let's read question 4. A ship leaves its harbor and sails due south for 10 kilometers. It then sails due east for 20 kilometers, then stops. Let's do a simple sketch. First of all, I need my directions: north, south, east, and west. And I call the harbor capital H. So ship leaves the harbor due south. So go down in south direction 10 kilometers, then sails due east, so turns to the right and continues for 20 kilometers, then stops. I call the last position of ship as S. Then in part A, how far is the ship from its harbor to the nearest kilometers is the question. So the direct distance between H and S is wanted in part A. So it is a right angle triangle between a movement between the south towards east has 90 degrees in between. So how can I get this distance? This is a basic right angle triangle. I'm going to use, because I know two sides and one side length is missing, I am going to use Pythagoras theorem. D is the hypotenuse, that's why I leave it alone here. D square on one side equals 10 square plus 20 square. So D equals square root of 10 square plus 20 square, and D is 10 square root 5, but to the nearest kilometer is wanted. When you see this exact value, you can press SD button to have the decimal number and do the approximation on the number that you see on your display. It is to the nearest kilometers 22 kilometers. So we finish with part A. In part B, it says, this was A. In part B, it says the ship wishes to return directly to its harbor. On what bearing must it sail? Give your answer correct to 3 significant figures. So bearing is the angle, and how many degrees must the ship turn until it reaches to its harbor directly. So I change my color of the pen. So I need a north on top of the ship's position. So this is the north on S, point S, and bearings is measured in clockwise direction. We are not going to measure it in this question, obviously. The diagram is not drawn accurately. We move in clockwise direction until the line HS. So that angle, very big angle, must be found. So within this turn, we have 3/4 of a full turn. So 3/4 of a full turn is 270 degrees. As you remember, one full turn is 360, and 3/4 of it, so 3/4 of 360 is 270 degrees. But this is not the answer, it's not enough. We have a small piece left in the right angle triangle. I will call this X. If I can find this value X, I'm going to add this to 270 degrees to have the answer of part B. So let's try to find x. This is a right angle triangle. I will use trigonometry. The side length 10 is the opposite side, and 20 here is the adjacent side length. So I will use tangent. Tangent of x is opposite over adjacent. It's 10 over 20. So how can I find the angle? I need inverse tan. So when I press shift button, then tan button, I will have inverse tan, and I will write down 10 over 20, close the bracket, and this value will be my angle left within the triangle. This is 26.565 blah blah blah. It's a long number, but it's not finished. As I told you, keep it on your display and add to this value 270 degrees and press equal. You will have 296.565, and it continues. Then do approximation. According to the three significant figures, your value is rounded to 297 degrees. Let's continue with question 5. Let's read first, then try to draw the figure. A helicopter leaves Bristol and flies due east for 10 kilometers. Then the helicopter flies 8 kilometers north before landing. Okay, so the first place was Bristol. I use capital B. A helicopter leaves Bristol and flies due east. East is that direction towards to the right. So it flies due east for 10 kilometers. Afterwards, the helicopter flies to the north 8 kilometers. So north is this direction. This is north, this is east. So it moves 8 kilometers in that direction. First east, then north. And this is the last position of helicopter. So I put capital H, indicating the position of helicopter. And in part A, the direct distance of the helicopter from Bristol, correct to three significant figures, is wanted. So the direct distance between those is this distance. I will call this D, and the movement here from moving to east, then changing the way towards north, has a right angle in between. I can, this is a right angle triangle, and I can use Pythagoras theorem to get the value of A, to get the value of D, which is the answer of A. So D is the hypotenuse. So D square equals 10 square plus 8 square, and D equals the square root of this, and according to the three significant figures, you will have 12.8 kilometers. This is the answer of A. And what else is wanted? In part B, the bearing is wanted. Calculate the bearing of the helicopter from Bristol, correct to the nearest degree. I'm changing my pen's color now. So the bearing of helicopter from Bristol. So I'm going to put north on top of Bristol and try to find the angle from north in clockwise direction until the line connecting the point B and point H. So this is wanted. This is the value I have to find. So how to get X? Let's think about it. I have a right angle triangle, and this is towards, this direction is towards to east, and this is towards north, and in between I must have a 90 degrees. So if I can find the angle within the right angle triangle here, let's say B, and then I'm going to take away this value from 90 to get the value of x, which is wanted. So let's try to find the angle B as I labeled with the letter B. The trigonometry can be used because the opposite and adjacent sides are known, so TOA, tangent, can be used. Tangent of B equals opposite over adjacent, so it's 8 over 10. I need to do inverse of tan, so shift tan, press shift, then press tan, will give you inverse tan. Open bracket, write the ratio, and you will reach the value of B, and this is 38.66. Then, as I told you, take this answer, so don't change it, keep it on your display, and write 90 minus ans, which is 38.66. This is on the memory of the calculator. You will get the wanted angle 51, and the bearing of helicopter from Bristol correct to the nearest degree is 0.51.